We're just going to look in the book. So anytime you multiply a vector, you're going to just, if you go 2 times it, it's going to make it twice as long. If you go -2, it's going to change the direction and double it down that way. That's what they're talking about on 28. And then they're saying that bottom of page 29, they're saying that what you do is you can take those vectors and put it in a matrix form, and then on 30, the vector equation, if you have x1 times a vector and then x2 times a vector, you can set it up as an augmented matrix with your vectors as the columns. And then when they're talking about a span, those vectors are going to create if you're thinking 3-dimension, they'll create a plane, and if you have a solution, it'll be in that plane. And would be the solution lays in that, on that plane. That'd be the way to visualize the span. And you could have B that represents a point that is not on the plane. Can you visualize that? You have this plane here, and that's the span of 2 vectors out in space. You have one that comes from here, top of Roland's head, and then one that goes out to that box over there. It's going to represent a plane, right? Now, if you have a B that represents a point that's on that plane, then that's in the span of those vectors. But if you have a B that lays away from that, someplace else out in space, then you will get no solution. That's what they're talking about. The span of the vectors is in 3 dimensions, is that plane. And then B will have a solution if it lays on that plane, has no solution if it don't lay on the plane. Does that make sense? So when they're talking span, that's what they're saying. And when you get to a vector that has more than 3 elements to it, then you can't visualize that. You can't talk visually what that is. But it still is span. It still is representing some kind of a thing like a plane, and then you only have solutions when you're in that span, and you won't have solutions when you're out of that span. And it'd be like a vector, 3 elements, where it constitutes a 3-dimensional space and a plane in that space. Does that make sense? So you got to kind of talk about it in terms of 3-dimensional space, what they're talking about, what span means, and then you just got to generalize it in your mind that there is this. It's some sort of a representation of something like a plane, and you're either in it or you're out of it. Span is what it is that the vectors represent, and the B is going to either be in it or out of it. Does that make sense? And that's what they're talking about for that definition there, where it says V1 through VP are in Rn. Then the set of all linear combinations V1 through VP is denoted by span. Right? It'd be like 3-dimension, 2 vectors, create a plane, and then the span of those 2 vectors is all that plane. And if you have a point on that plane, then you'll have a solution. If you don't have a point on that span, that plane, you won't have a solution. Because what it is you can, in the plane, you can take 2 vectors and you can find any other point on that plane by multiplying each one of the vectors by some combination, right? That'll add to that point. Does that make sense? So the rest of it says the span of V1 through VP is called a subset of Rn spanned and generated by V1 through Vp. The span of Vp is a collection of all vectors that can be written in the form of C1, so on. So you can just create a vector that will go to the B point on the span. You good enough? And then they're talking about, they'll go through a geometric explanation. You can read through that, see whether that makes it clearer for you. Now the nice thing about the span is if you do an augmented matrix of the B value with your vectors, and if you can get a solution to that augmented matrix, then that means that that B value is in the span. And it will have solutions of whatever you have, and those solutions are going to be what you multiply by your vectors in order to get that solution. So okay, on page 32. And look at number 2. And it says, in exercises 1 and 2, compute U1 plus U2 and U1 minus 2U2. So U is the vector, it's the vector 3, 2. So that would mean a point in two-dimensional space at x is equal to 3, y is equal to 2. And then b is equal to 2 minus 1. And then if you add those two vectors, and adding the vectors is what you get the 2 points, and then you do a parallelogram, and then you run from 0 out. That's how you get, see, like if this thing is, if 3, 2, and I'm going to avoid using the stinking graph, because I think therein lies the problem. Get this someplace right here. So x is 3, y is 2 is going to be some kind of a point out here, right? And then x is 2, y is 1 is some point down here. And then we run vectors out. And then if you multiply a number times that vector, you would go someplace. You'd be on that line someplace, right? And you can get wherever you want. But if we do a parallelogram here, if we add the 2, that's that, right? And that's that vector right there. Correct? So U plus V. Let me get this. It's going to be 3, 2 plus 2 minus 1. And you just add the 3 and 2 is 5. Then the 2 minus 1 is 1. So it should be 5, 1. And that should be this point right out here, right? That's what that vector would be. And it's, when you add, you're doing that parallelogram. So then if you're doing U minus 2V, so the V was this one right here. So if you're going to go minus 2V, They're going to go back in this direction, right? 2 times that. And then you're going to combine that with this one. And you should get then this vector that goes back up here. This seems to be having lots of trouble. 3, 2, minus 2, and 2 minus 1. So that top one's going to be 3 minus 2 times 2. The bottom one's going to be 2. It's going to be minus 2 times a minus 1 is a plus, right? 2. So my new vector should be minus 1 and 4. Not too good of a diagram, but that's what it would represent. All right. I'm going to do in exercises 5 and 6. It says write a system of equations that is equivalent to the given vector equation. Okay. What are they asking us to do there? 6. This is a little slow. I'm actually writing the number, and then it shows up there a little bit later. That's kind of 6 minus 2. That sounds like a jet engine starting up, don't it? Gradually winding up. So the series of equations are going to be minus 2x1 plus 8x2 plus x3 equals 0. Do you see where I got that equation? So that maybe you this is minus 6 x3 equals 0. So that's all they're wanting you to do. Okay. In exercises 9 and 10, it says write a vector equation that is equivalent to the given system. That's 4. So we want to write a vector equation. So what we have is we have an x1, and then we have a vector which is 4, 1, 8, right? And then we're going to go plus x2, and we have, would it be better if I do intermediate step? Like if I wrote this as, this one here as 4x1, x1, and 8x1, then pull the x out. You understand what it is. 1 minus 7 and 6, and then plus x3, 3 minus 2 minus 5 equals 9 minus 2 and, no, I don't know where I got the minus. It was in my head. 50. Now, what you want to do with these is these values. If you change this sign, if you put a negative sign here, then you better change all those signs here. Right? But it's best to just put the positives and then have the signs for the different values here and take care of it that way. Pretty straightforward. Now, in 11 and 12, it says determine if B is a linear combination. So all we're going to do is take those vectors and put them in an augmented matrix and then set it equal to B. So those what it's doing is those vectors, we're just checking to see what the weights are for those vectors, so that B is in the span of those vectors. So we have A1. So my augmented matrix should be 1, that's 2, and then it's 0, 5, and 5, that's 2, 0, 8, and then augment it. And then we're just going to do echelon and reduced echelon, and that will tell me. And I guess if B is a linear combination of, so all I have to do is get an echelon form, make sure the last row, isn't 0 equals something, and I know that there is a combination. It's not saying what is the combination; it's saying is there. Now what I'm going to do is I'm going to multiply the first row times 2 to eliminate the second row. Did I do it right? Now I'm going to go ahead and eliminate make a 0 in the bottom left-hand side. I can do this all at the same time. But I just got to go back to I'm going to multiply a minus 2 times the first row. You with me? Simone. Okay. I can see the spelling, but I can't see the pronunciation. So I'm going to multiply first row times a minus 2 and combine it with the third. So this is 0. Then this is 5. I'm doing a minus 2 times the first row, so that's a minus 4. That makes this 4. Minus 2 times the first row makes that 10. Minus 7 is 3. Did I do it right? This is where when I'm doing problems, and if I'm a little bit tired, I can multiply and add and come up with the craziest numbers in my head. Now, we got two choices. We can either take that second row and get 1 where the 5 is, or we can take the second row and make a 0 underneath that 5, where that 5 is. I'm going to choose to put a 0 down underneath. Okay? So that means that I would have to multiply the row that has the 5 in it, this row right here, times a minus 1 and add it to the bottom, correct? So I'm going to go 1, 0, 2, minus 5. Then I'm going to go 0, 5, 4, 1. And then multiplying 1 times the second row and adding it to the bottom, so it's 0. And this is 0. 1 times 5 in the second row is minus 5. Plus 5. And then 1 times 4 in the second row with the bottom row is 0. 1 times 1 and combine it in the bottom row, and that's 2. So, we have pivot. These are pivots. But what about that bottom row? It means there's no solution, right? And therefore, the statement that says, determine if B is a linear combination of those three. It's not a linear combination, right? In order to be a linear combination, what would this thing have to be? 0, right? So it's not a linear combination. Nice thing about all this stuff, it's all going back to what we did in the first one, where we're doing augmented matrices and looking for solutions. We would say this is an inconsistent set, right, of equations. Now 13 and 14, it's saying determine if B, did I do this? Is no linear combination of the vectors formed from the column of matrix A. So this is just the same thing we just did here, right? We just do an augmented matrix. Formed by A and B. So it's 1, 0, 1. Minus 2, 3, and minus 2. Minus 6, 7, and 5. And then augment it with that B. 11 minus 5, 9. And then we're going to try to get it in echelon form.
It's not saying what is it.
All we have to do is go to echelon form. So the first and second row we don't have to worry about, right? Because we got 0 underneath that leading pivot point up there in the first row. Now the third row, we're going to have to multiply the first row by -1, right? And then combine it. So that makes this one 0. We do a -1 times -2 is a +2 in the second column. Add it to the third row, and that makes it 0. -2 times the -6 is a +6. Add it to the third row is 11. And then a -2 times 11 is a -11. -1. I don't know where I got -2. -1 times 11, -11. This is a -2. Now you notice our pivots are here, and that thing has a solution, right? If we did a reduced echelon form, we could get the solution, which would be the weights of the vectors to get to that B. But it's only asking us, determine if B is a linear combination of the vectors formed from the column matrices, and if we get it in this echelon form, and our last row, is not something with a 0 in every place. As long as this thing is not 0, and this, we don't care what it is. But if this one right here is 0 and this is something other than 0, we're in trouble. It's inconsistent. We don't have a linear combination. Now, if we wanted to find the linear combination at this point, we'd have to do reduced echelon, and then whatever our last column would be, those would be the weights for our matrices to get to B. Correct? Okay. If we look at 18, it says values. Oh, here you got your vectors. For what values of H is Y in the plane of V1 and V2? V1 So we set this up in an augmented matrix, right? And row 1 and row 2, this is really aggravating me. close the program.